Hello students, the purpose of this video is to get you acquainted with exponents and exponent rules. So when I think about an exponent, there's some vocabulary words that we want to make sure we feel confident on. And the very first one is the base. So any number that is going to have an exponent on it, that's going to be your bigger number, your base value. And so we call that our base number. And then we have that small little number, and that represents our exponent. And what the exponent does is it tells us the number of times we want our base value to occur. And so it's a number that's going to be multiplying itself a certain number of times, and we determine that certain number of times by the value of our exponent. So here I have 5 squared, and you see that I've written 5 times 5. So that's telling me that I'm going to take the base 5 and multiply it by itself 2 times. Now, when speaking about this expression, we say 5 raised to the second power or 5 squared. So we want to make sure we're using the correct lingo as we discuss, base values and their exponents. We don't want to say things like 5 to that little 2. We want to make sure we're using our proper vocabulary terms. There's some different properties that we want to feel confident on. The very first one states that anything raised to the 0 power equals 1. So whether this is a number like 2 to the 0 power, or 5 to the 0 power, or 100 to the 0 power, all of those are going to equal 1. Same thing if it's a variable. If it's x to the 0 power, y to the 0 power, a to the 0 power, regardless of the variable, if it's being raised to the 0 power, it is always going to equal 1. Our second property states that we don't want any negative powers. When we are simplifying exponent expressions, negative powers are not considered simplified. So in order to get rid of a negative exponent, in order to make it positive, we are going to move it based off of its current location. And so I say it like this because in this example you see here, a to the negative m, a is a base value that is basically a whole number. So if we think about this in a fractional form, this is over 1, right? It's not a fraction at this point. So I'm going to move that value to the denominator, as you see I've done here, and what happens is my exponent becomes positive. So I want to show you a few different circumstances. So let's say we had 2 to the negative 3. Then when I move that, it would become 2 to the third power. If I have something that's already in a fraction form, maybe I have 1 over x to the negative 5 power. Because that's already in a fraction form and it has a negative exponent, since the value is in the denominator, I'm going to move it to the top, and that is when it will become positive. Another thing that can occur is me having something like 3x to the negative 2 power. When I simplify this, I'm going to keep the 3 on top, and I'm only going to move the x to the bottom. The reason why is in this property, we only want to move what needs to be moved. And you want to keep in mind that 3 is its own number and x is its own variable. 3 currently has a positive exponent of 1 on it. If you were to move the 3 to the bottom, it would then have a negative exponent of negative 1, and we don't want that. So you only move what needs to be moved. Another circumstance that you could have is something like negative 5 to the negative 2 power. This rule is talking about the power. It is not talking about the value of your base. So I know that I'm going to want to move that to the bottom of my fraction in order for that exponent to become positive. And a common mistake is that people write the base then as a positive 5. You don't want to do that. The value of your base, which is negative 5, is not going to change. The rule only applies to the exponent value. Another property of exponents states that when you are multiplying two values that have the same base, then you're going to keep that base and you can add their exponent values together. And this comes in super handy. Again, the key is those base values must be the same. When we look at distributing means to multiply. So here I have a value inside of parentheses and I have an exponent on the outside. I am going to take that exponent and distribute it to every single thing on the inside, and whenever I distribute, I multiply their exponents together. This property is stating the same thing, but it's showing you what happens when you have more than one thing inside of your parentheses, more than one base. You're going to distribute to both items so that both bases get that exponent value. The next property talks about division. If I have two values that have the same base on top and on bottom, and the operation is division, I'm going to subtract their exponents from one another. Now, I encourage you to pause this video and think about this question, is there a difference? And maybe utilize your calculator and solve each of these to see if you notice anything different about each of these expressions. Now, what I'm going to tell you is, yes, there is a difference. The main difference here is regarding my parentheses. And then when I don't have parentheses, and you notice that that's kind of the difference in all of these different problems. The idea is that when I have parentheses and an exponent on the outside, as you do see I have in this first one, this is stating -2 times -2 times -2 times -2. So the exponent is stating that this entire base, including the negative, is going to occur 4 times. Whereas on the second problem, I have a negative sign, and then I have 2 times 2 times 2 times 2. So you notice that that fourth power is only to the base of 2. The negative is not associated with the base. It's very critical to pay attention to those parentheses when you have them versus when you don't, because it will make a difference in your final solutions that you get. I have some practice problems. Again, I encourage you to pause this video, work these out on your own, as I'm going to begin working on these and providing the solution. So you want to make sure you're giving yourself some practice. Now, as always, there's different ways to approach the problem. There's not just one way that you have to go about doing these problems, but I'm going to show you the way that I would approach these. Looking at my first practice problem, this is not considered to be in simplest form because I have a negative exponent. So I'm going to go ahead and correct that, and it is going to be 1 over x to the 5th power. On the second expression, I'm going to go ahead and keep the 6 because that has a positive exponent, so I don't want to move that. But I'm going to move the x to the 3rd to the top so that it becomes positive. On the third expression, I'm going to start by distributing that -3 to everything on inside of my parentheses. And then to simplify, I'm going to move everything to the top in order to have a positive exponent value. On this fourth expression, I'm going to compare values on top and bottom. I'm going to compare values that have common characteristics. So here in orange, I've highlighted numbers, and I have the value 7 over 8. And you want to ask yourself, does that fraction simplify? It does not, so I'm going to leave 7 on top, and I'm going to leave 8 on bottom. I'm then going to move to my A values that you see I'm highlighting in red. And because those are one's on top and one's on bottom through division, I'm then going to say, okay, I'm going to be finding a to the 5 minus 6, which equals a to the -1. So I'm going to go ahead and put that on top. Next, I'm going to go ahead and look at my V values. You see that I'm writing that in purple. So when I go to write that out, b to the 3rd over b squared, that is going to be b to the 3 minus 2, which equals b to the 1st power. So I'm going to go ahead and write my b on top. And I need to further simplify that. I'm going to leave my 7 and my b. I'm going to leave my 8, but I'm going to move the a to the bottom so that its exponent is no longer negative. I've provided 2 more practice problems. Again, I encourage you to pause this video before beginning to work on these so that you can get some practice, and then once you come back, I'll be working on the solutions. So again, on number 5, I'm going to break these up by their base values. So I'm going to compare the numbers first. So I see that I have 12 over 3. That actually does simplify, and that simplifies to the number 4. So I'm going to go ahead and put 4 on top. I'm going to look at my next value, which I'm highlighting in red, and those are my a values. And when I simplify that, I have a to the 3rd minus a negative 2. So remember, division says to subtract, and you end up with this situation where you have double negatives. So you want to be careful of that. And that gets you a to the 5th power. And then looking at my b values, as you see I'm highlighting in orange here, I have b to the negative 4, and I'm subtracting, and then it's a 1. And that actually gives me b to the negative 5th. So I actually ended up with no denominator value in this case. I'm going to go ahead and get rid of that. Let me write. I messed up my 4, okay? So I didn't end up with a denominator value, but I do want to simplify this. I'm going to keep the 4, I'm going to keep the a, and I'm going to move the b to the bottom. For my last example, I'm going to start by distributing my negative 2 to everything, and I need to distribute that to the top and to the bottom. So that's going to give me 3 to the negative 2, x to the negative 8, because distribute means to multiply exponents, x to the negative 2, and then y to the negative 2. And it appears that everything has an exponent, so everything is going to move. So I'm going to have x squared y squared on top, and I'm going to have 3 squared x to the 8th on the bottom. And then because I do notice I have an x on top and I have an x on bottom, I can further simplify those, and that would give me x to the 2 minus 8, which is x to the negative 6. So when I rewrite this, I have x to the negative 6 y squared all over 3 squared. And I don't like that x on top, so my final answer would be y squared over 3 squared x to the positive 6th on the bottom. As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out.